Yeah, so hi everyone. So let me introduce myself once again. My name is Aditya Ganesh, and I'm a student at the IITB Monash Research Academy. I'm doing my PhD here, and at present, I'm in Australia in Monash University. And as a part of the Prime Minister's Research Fellowship, I'll be conducting a course for you all in SCILAB. And yeah, so let's get to the course directly. We'll start off with installing Scilab. I did see Joshi sir writing in the group that you all should install, but still, if someone is left behind and has some issues, we can get that done here. I'll share my screen. Yeah, I hope the screen is visible. So you have to just search in for Scilab. And then once you go here, you'll be downloading the software from here. Depending on your requirements, you'll have to install this. I have a Windows system, so it is the 64 bits that I install. If you have a Mac, you can install either of these. Yeah. And once this is done, you'll get this executable file which you have to run. Just accept all the permissions, and once that is downloaded, we can proceed further. Um, has someone, is there someone who has a problem and doesn't have Scilab installed in their system? You may raise your hands or, yeah.
If anyone has problem, write in Q&A.
Because all these sessions will be worthless if you don't have Scilab installed.
Correct.
There is no online version of Scilab available, as far as I know.
Yeah, that's
so
true.
you'll have to work with Scilab by downloading it. Um, so yeah, assuming all of you have installed the Scilab application. So once you run your Scilab application, it will look something like this. So here you have multiple sections. So we'll go slowly. So towards your left-hand side, you have your files. So you can handle your files here. So you can see, I'm in my documents folder here, right here. And then this is the main part of your Scilab, where I will be running your codes. And yeah, we'll be exploring this. The variable browser is where you store all your variables. Whatever you write on your console would be visible here. So this is the place where you can see what kind of memory has been allocated to your variables, and what are the shapes, what are the values, what is the type of the variable, and how much memory it stores. Then here is your command history. So uh, whatever instructions you're typing here would be stored here, and this is something that you actually don't need. You can even close it off. This is the default of Scilab. So once that is done, you may rearrange your windows like this. If you want, you can even hide your file browsers, uh, make it shorter and make the screen look bigger. Okay, so I hope this text size is okay with you. Just see if I can zoom in. I guess this should be fine. So yeah, let's start with the basics of Scilab. So yeah, so we usually will be testing our functions here in console, and then the main programs will be writing in a text editor, and then this is where your codes are being will be executed. So we'll start off with assigning a variable. So let us just type a is equal to, just give some random number that you like. Let us say 3. So once you hit enter, you will see two things that happens. So one is that you get a is assigned as 3 is being printed out here. And the second thing is in your variable browser, you will see several things out here. So you'll see the variable name a has been stored, which has a value of 3, and it is of the type double. So for now, let us think of double as real numbers. So doubles are real numbers. The visibility and memory is something you can see. So visibility is like, yeah, it is available temporarily. And this is the amount of bytes. This is the 216 bytes of memory is what this value of 3 stores. So this is how you assign a variable. So you can also assign a different type of thing like a string. So what is a string? So let us say B is, let's say hi. So now you can see here the same thing, two things appear here. So B has been written here, which says hi. And to your right, you see the name B over here, variable name B. It is of the shape 1, comma 1 cross 1, and it is of the type string. So what is a string? String is something that has text and characters. So and it comes under these single quotes or double quotes. So yeah, so either ways, you can either write single quotes high or you can write double quotes high. It will accept it as a string. And yeah, so visibility is something that you can ignore. Let me see if I can hide that. Okay, that doesn't go off. Yeah, so and the third thing is uh, true or false. So true or false is known as Boolean. So those who have learned logic and stuff in mathematics would understand what true or false is. So percentage t is true. So if I assign that, you'll see here again, c has been assigned as true, and it has been stored as a Boolean. And once that is done, you can also store c as false. So let me override this stuff. So now I don't want c to be as true. I want it to be as false. So I'll write percentage f. And this time I don't want to print stuffs. So what I'll do, I'll put a semicolon. So once I do that, you can see nothing has been printed, but here the Boolean would have changed. So to check if the Boolean has changed or not, you can just type in C. You can see C has been updated to false. So these are the main types that we'll be dealing with. We'll be looking into more advanced types later on. But for now, these are the three types that we'll be dealing with. So let us go. Yeah, so let us start off with clearing this session. So to clear this, we'll be using CLEAR, clear. So once I type this clear, you will see that all these things would vanish off. So once it's clear, you see the memory has been erased. So now if I type A, it doesn't know what A is, it doesn't know what B is, it doesn't know what C is. So we have erased the memory. Then the second thing is CLC, clear. This is clear screen. So once you hit this, you will see a pop-up, and yeah. So and this pop-up would say that are you sure you want to clear the console? So for the first time, those who are doing it, please click on this because we'll be using this function quite frequently. And once you do this, you hit yes, you will see this entire console has been cleaned up. So these two are the main things. And then you also have the CLF, which now would, if I just enter, nothing would happen. And then it would clear the figures. Yeah, since there's no figure, it's just showing this thing, but it's good to write clear figures as well. And then once that has been done, yeah, so I'll just hit CLC once again. Yeah, so this is where we start once again. So let me write our first operation that we are doing. So this is going to be addition of two numbers. So whenever you write something with these two slash marks, it counts as a this is a text that we want to write. So it will just overlook this. It will not execute anything here. So whenever you want to write comments in your code, so for that you will just write this. Okay, so to add two numbers, let us say we have two numbers. A is 1. I put a semicolon. I don't want to know what A is, and say B is 2. So once I hit this, I have stored A and B. So now I want to do A plus B. Once you do this, you hit enter, you see the answer is 3. And this time there is a variable name, a default variable called answer, which has this addition of 1 and 2, and the value is 3. So this is how addition is done. In a similar manner, let us do subtraction. And here we'll be doing A minus B. And that should give you a negative value. Yeah, and that is -1. So you can see the answer has been updated. We didn't assign what A minus B is. So if I say C is equal to B minus A this time, you can see C is 1 and it has been stored here. So whatever you work here will be visible here. And if it is visible here, it's easy to actually see if what you're doing is right or wrong. So here everyone knows B minus A is going to be, that is 2 minus 1 is going to be 1. And in general, we'll be writing the code like this with a semicolon. So we actually won't know what's happening, but we can refer to this place to ensure that addition and subtraction have been done clearly. Let me hit clear screen once again. And now the third thing that we do is we multiply two numbers. And for that, A and B are already here. Since I just cleared the screen, you can see the variables here. If I want to clear this as well, I'll write clear and everything will go off. And now I don't want that. So for now, let us say I want to multiply B with B. So you can use the same variable again here. So this is equivalent to B square. I want to see what 2 square is. So I'll hit enter and then you can see 4 here. Now the answer has changed to 4. I can assign this as B square minus 2 times A. This is something, yeah, you can also do, you can use you can use multiple variables at a time. And then you'll see that, yeah, you can get some value out here. And the final thing that we want to do is we'll be dividing two numbers. And that will be equivalent to, let us say I want to divide the answer with B or C. We can just do answer divided by C. You get the answer as 2. So in this way, you can also use the answer in your code and then like kind of get the answer and use it once again. So now the answer is 2 if I rerun the same code. So you can also use your up arrows and down arrows to like go back to the previous command that you've used. So I'm just going back to this command here as answer C. If I hit it, now it's reduced to 1. If I rerun it, it'll be 0.5. Like every time it's getting reduced by 2 because C is 2 and the answer is 0.5. Now, if I run this again, it'll be like zero point 0.5 divided by 2. That is 0.25. If I run it once again, it'll be 0.125. So these are the main things that we have to do. I mean, these are the basic things that we need to know initially. Yeah. So any doubts in this in the application while running your codes? So I hope this is clear to you all. I don't think you really would be confused here because we are just doing multiplication and division. So we'll move on to the next part, which will be basic functions. So yeah, let's go back to there's someone waiting out here. Okay. Yeah, someone has a doubt here. Bhavish, if you have a question, please type in the Q&A box. I'll come to you once again. Yeah. So let us proceed further. I'll clear this section. And then let us go to some of the basic functions. Let me also clear all the variables. And yeah. So let me rewrite. Let's say x this time. X is equal to 2. And now I want to run some functions out here. So let us see the basic functions. So exponential is given as exp of 2 or exp of x, exponential of x variable. Once you hit enter, you will see the value of exponential of 2. You can verify it as this. So the answers are the same. You can see 2 is being stored as a double value. And yeah, and you have your answer as the exponential of 2. So this is the exponential. Then you have the logarithm of x, and that is 0.6931. Yeah, this is the value of log 2. You also can calculate the logarithm to the base of 10, and that is 3010. I hope you all know these values. Um, and once that is done, you also have square root of 2. So you write sqrt. So these are some basic functions that you need to know. The square root of 2 has this value. I hope you all know all these things. I mean, you need to know the logarithms of 2 and all these stuffs. So for various entrance exams also to get calculations done fast, if you know the logarithm of 2 and stuff, you'll be able to uh, go do things quickly. Yeah. So this is the square root of 2. And then let me clear this section. And after this, you can also do, so we'll also be dealing with certain numbers that are fractional. So let us say A is equal to 5 by 2, or say 5 by 3. So you have this 1.66 as A. And now let us say you want to find the nearest integer number. So you can just you can round off this number as a round of A, and that will give you 2. And then for certain purposes, you might, this A variable might vary. So it could also be 1.4, it could be 1.6. So let us say if A is equal to 1.4, and now you hit round, the answer is 1. So round A will give you the nearest integer, but you'll store the value as a double value here. So you can see here, the type is double. That is, this 2.0 is what it's storing. And once you do that, you can see, yeah. So if it is 1.4, it rounds off to the nearest number. So let me go back to 5 by 3 and clear my screen. So A is 5 by 3, which is 1.66. So let us say I have A as 1.66, but I need the number to be 1. I want to near it to the lowest, rounding off has to be done in such a way that I get so 1.6 is between 1 is less than 1.66667 and is less than 2. This is the possibility of you either get 1 or you get 2. So now there are certain cases where you get this fraction, you might need to get the value as 1. You need to find the integer that is on the lower side of the spectrum between 1 and 2. So for that, you do something known as flooring. So floor of A will give you 1. It'll give you the lower integer, and ceil is something that will give you the higher integer. So floor and ceil is something which is very, very important. And yeah, so when you do calculations, so you might need to figure out the time steps of your in your iterations. And then you might say you have 10 total time is 10. That is t is equal to, let me, yeah. So t is equal to 10. And then you want to run this for, let's say, the time steps are somewhat fractional, 0.33, something like this. And then you will see that the number of time steps here would be t divided by dt. And that is not, you won't get an integer value out here. So you will be using these values. Depending on your system, you might either floor your system or take the lower value of your integer or higher value. So if you do round and you really want to be safe, then you would do ceil. And if you want to be around 1, then you would do floor. So these two are the yeah. So these are the basic functions that you might need, and then over time we'll be exploring other functions as well. So any doubts here with round, floor, and ceil? Okay, great. I see thumbs up. It's good if you react because since you have kept your videos off, I don't know if you can really understand or not. Uh, eh, does someone have a doubt? Okay, okay, fine, fine. Okay, you're raising hands. Fine. Do you have a doubt or is it fine? Those who have raised their hands. Okay, I guess it should be fine. So let's proceed further. Let me clear this section. And then we'll look at some important constants as well. So pi is something that we need, that we use for every calculation. So the reserved word for pi is percentage pi. And once you hit this, you'll see the value of pi appearing. And this is what we usually use for calculations. Your assignments would be based on this. You would have used it plenty of times. And you also have your exponent E, and that is given as percentage E. This is your Euler's number. So these are the two constants that you need to know as of now. Yeah. So these are the things. And then let us say you have a number. Yeah. You have a number out here. Let us say 1, 2, 3. A is equal to 1, 2, 3. And then you want to convert it to a string. It is called string of 1, 2, 3, string of A. Once you do this, you can see A has changed from, yeah, the answer is a string. You can assign this as A. A is equal to string. So 1, 2, 3 is, even though it's a number, once you hit the string operator, you see that this has been converted to, I mean, it is not, you cannot do addition or subtraction with this. So if I say A is equal A plus 3, if I say this, it's not 126, it will give you an error because now this is a string. So, and strings are like just characters. It is equivalent to something, it's like an ABC. So you're just storing this as a string value. You cannot do any operations further. So let us say if I really want to, I have a number like this. Let's say the reverse case. I have something like 1, 2, 3 as a string, and I want to use it as a number. So for that, you have this str to d function. And now this is a number. You can see the answer has been changed to a number. So many times what happens is you'll be given these these files wherein you have to read your numbers out. So once you read these files, I mean, in the files, let's say it's a .txt file. So in the .txt file, there'll be several numbers. So once you import that in your Scilab code, there'll be string of numbers. Now you have to convert it to numbers from strings. So at that point of time, you'll use a string to D, that is string to double. You can keep that in mind. str to D, that is string to double. I'll just write this down. str to D. Yeah, this is what strtod is. And this is quite important for us. And then you'll also have many cases. So you might not just store a number. So let's say your file is something like this. Um, let's say 1, 2, 3, comma 4, 5, 6, comma 7, 8, 9. And then the next line would be something like the same. I can write 1, 3, 5. So your file will have these numbers like this and multiple rows like this. So you need to read every line out of this. So the thing is, you'll get once you convert this into a number, it will be like A is equal to. So let us take line by line. Let me copy this and paste it here, and let me introduce double quotes here. So now A is a string, and now if I do string to D, it won't give me the answer that I need. It gives me 1, 2, 3, and that is not the entire stuff. You need 1, 2, 3, you need 4, 5, 6, you need 7, 8, 9. So for that, you have this delimiters, wherein you can say that, okay, comma is my place where I need to separate. So let us say you have, so the function for it is, and you can say the delimiter as, okay, so it's, yeah, so the function is something like this where you can, stro, okay, so in case you have a doubt with the function, you can just go to this question mark out here And then here you'll get all the functions out here, and you can search for different kind of stuffs out here. So yeah, you can see multiple things here. You'll find Scilab stuffs variables out here. You can see what different variables are. So we use clear, so you can see clear how it works. You have, like, if you want to clear particular variables, it looks something like this. Then you have some constants. For instance, here is your epsilon, the Euler's number. Uh, sorry, yeah. And see how Euler's number is being stored as. So you have Euler's number stored as 1 over n factorial, and this is summed up. This is how Euler number is stored. Similarly, logarithm will also have its own exponent, I mean the summation series. You can see infinity out here. You can see pi. You can see not a number. And yeah, you can see true or false also here. Then yeah, these are used to define polynomials. So you have multiple things out here. Yeah, so you can look for, if you're having any doubts, you can just look here. So as of now, I don't think you'll be needing these functions. So we'll just skip this part. So yeah, but there's a function that will like separate this as 1, 2, 3, 4, 5, 6, and 7, 8, 9. I'm not sure if I've written the name properly, but yeah, yeah, you'll find it out. Let me clear the screen. And then once that is done, we can look at vectors and matrices. So mainly we'll be working with vectors, matrices in our codes. So this is something that you need to know really well. So let me define a vector v, and this will come with these box brackets. So just inside this, you have to enter numbers. Let me just give the heading for this, vectors. And then here you have b is 1, 2, 1, 2, 3. And then let me put a semicolon. So once you hit this, let us see here. So we have 1, 2, and 3 as our values of v. It is a double. So these numbers are all real numbers. And now let us print v. So once you hit v, you see v is 1, 2, 3. A better way to do is to just write display v. So this is how we'll usually print these vectors. So display is something that we need to know. You'll also be writing this a lot in your codes. So once you write in display, you will see 1, 2, 3 out here. You can also write a column vector. So this is a row vector. Wherein you write 1, 2, 3, you can write VS 4, 5, 6. You can either write it without commas or with commas. Okay, with commas. Yeah. So you can write it without commas or with commas. So either ways, you'll get the same thing, wherein you have 4, 5, 6. So I would recommend you to write it with commas. Once that is done, you can also write them as column vectors. So for that, what you do is you'll write the same 2, and then you'll put a semicolon, then 3, semicolon, and 4. So in this manner, you will get a column vector like this. And here you can see you have semicolons here in your values. So 2, 3, and 4 are your numbers in this W vector. And yeah, it's a double. And yeah, so you can also store a single number as a vector. So here to identify if it is just a simple parameter or a variable or a vector, you can just see these square brackets out here. Um, Yeah, so that will differentiate. So you can also write something like, let's say, wx is equal to 2, like this. And then you can see, yeah, so this is stored as a single value. You can write y is, yeah. So this is also stored as a parameter. So yeah, these are the basic things with vectors. You can add vectors, the same stuff, v plus w. Yeah, okay. In this case, you can see that v is 4, 5, 6, w is a column vector. So you need to transpose this, transpose either of these vectors. So let us transpose v first. So what is v transpose? Just put a this thing parenthesis out here, and then you'll see that 4, 5, 6. It was written here as a row vector. Now it has become a column vector. So once it's a column vector, it's easy to add with a column vector. So you can see we have added these two numbers. In a similar way, you can also convert the w vector into a row vector. So here, so let's print w. W is a column vector now. W transpose is now a row vector. So to convert, yeah, so we have done this thing. So you can write v plus w prime. And this is 6, 8, 10. And we have it in the row form. So this is 1 cross 3. And this one you can see here, v prime plus w is 3 cross 1. That is 3 rows, 1 column. And v plus w prime is 1 cross 3 value out here. And now since we have the answer, so I hope this is clear to you all. Any doubts? I mean, yeah, I'll just halt here and ask if you have any doubts here. Yeah, fine. Yeah, so we have added two vectors. Now we need to figure out which variable is what. So now we need to access individual elements of these values within the vector. So to do that, so let us consider vector v. I'll just clear the screen. So v is 4, 5, 6. I want to access the first element. That will be 4. If I want to access the second element, be written like this, and that is 5. And the third would be the same thing, v of 3. But for now, I would say I don't know how long v is. So in that case, if I need to access the last element, I would do v dollar, and that'll give me the last value. So it doesn't matter how far this thing is. I mean, if it is 1 cross n, it'll return v of n, and that is what this dollar sign is. For those who have done the Python course with me, this is equivalent to something like v of -1. So it gives you the last element. You can also access the second last element as v dollar -1. So it is like n minus 1. So here n is 3, 3 minus 1 is 2. So it will give you 5. 5 is your answer. This is the second element. So this is how you access elements of vectors. And yeah, so that is something out there. And then you also have something known as cells. We'll cover that as well. So vectors are there, then there is cell. So you can assign a cell as this thing out here. So you're just giving two empty cells where you can store memory. You can see comparatively it is a little more over here. And then to access these memories out here, you'll just write 1, comma 1. So this is the first element out here. And then you can store a vector out here. Let's say 2, 3, 4. So now we have stored. So this is A. In your first memory, you have stored a vector. In the second, you can say you have stored you have stored strings. So let's say hi. So you can see here, right? This has three elements. This has two elements. So you can do whatever you want with your um, cell here. I mean, basically, if you want to store a table out and you really want to partition stuffs and keep everything neat, you can use a cell. Otherwise, I don't think we will be using cell in this course further. So this is just for your knowledge. We'll be storing variables and tables directly as a vector or a matrix. But this is something that is good to know. And then there is also something known as struct, which is an equivalent to object-oriented programming of any kind of programming languages. So I'll just write down that for you. So let us say you have something like a reactor, and then in that you have a struct, and then you say you have a temperature, and that has, let's say 25 degrees, and then it has pressure, it's 101, just 101.2. And then let me close this. Yeah, so you can see a reactor has certain values. So reactor is the main object. Temperature and pressure are its attributes. So you can access stuff like this reactor dot temperature. You can see the value is 25. So in this manner, let's say you have thousands of reactors. You can just say reactor one, reactor two, and then say reactor one dot temperature is something. And then with these objects, you can really, construct a network out, and then yeah, you can balance stuff. So this is object-oriented programming. We'll see if we have time towards the end of the course, or if someone wants to really do a network project, can work with these structures. Yeah, so that is it about structures. And then after that, I think we can move towards matrices. Or yeah, before that, we can also play with figures. So let us say you have X is, so we'll be plotting some stuffs out here. So let's say figures, plotting figures. In this you have X is equal to, let's say 1, 2, 3, 4, 5. And then Y is 1, 4, and yeah, use commas 4, 9, 16, 95. I'm just squaring stuffs and just writing it out here. And then once you do this, you can write plot X comma Y. This is the simplest way to plot. Once you hit this, you will see this graphic window appearing. So this is a line out here. You don't have any labelings out here. So yeah, as you go, you can write figure. Once you plot this, you can see figure properties. Yeah, you can edit the axis and all those things. Several things you can do out here. We'll explore this later. Um, yeah, you can move in the plot somewhere. You can zoom in, you can zoom out. So all these features are available here. So I'll give you time to play with this. Let's see if you can plot something interesting out here. So here you can see that these are like quite discrete points. So if I want to, okay. So if I want to now plot X and Y, this time I want to really find out where these points are. So I'll just write dash O. So this is going to plot my data out here. So you can see there's 1 point here, 1 point here. I mean, all the 5 points are like demarcated quite well. You can close this. You can also write it as, let's say I want to change the color. So here you can see I've written dash O. Dash O means the lines are connected. Zero is the circle marked out here. R is the red color. So this is how you can like type in OG or some other thing. You'll have a list of different type of markers out here, and you can also give other attributes here like so here you can see I've written title as squares, and here you can see squares written here, and then you can also label other stuffs. So X label is some X axis. So once I do this, you can see X axis out here written here. And then if you do the same thing for Y axis, you'll get this. So I'll give you some time to play around with this. You can just work something out. Or rather, let me teach you something and then you can try some function out for yourself. Yeah. So yeah, you can also work out with exponentials of these values. So let's say exponential of X. So you have these values. You can store them as your Y. And then you can plot these values. So exponentially, you can see how it's increasing. You can also plot logarithms. These are logarithms. So different functions you can plot here. And then, let us also explore writing vectors in different forms and with equal spacings. So for instance, let us say you want to write numbers between 1 to 10. So our V vector is going to be 1 space 2, 3, 4, 5, 6, 7, 8, 9, 10. This is what you want, but you don't want to keep writing like this. So what you would do is you would say V is equal to 1 is to 10. You can see the same thing out here. So this is to operator is like it goes from 1 to 10 in with the steps of 1. So this is an equivalent thing to say that, so 1 plus 1 is 2, then plus 1 is 3, 4, 5, 6, and so on and so forth. So you can write your step out here. So for instance, if I write 1.5 and then 10, this means that it goes from 1, then 1.5 to 2.53, 3.54, 4.5. And then this will keep increasing forever. So you can like make really big matrices, I mean vectors out like this. You can see the step was so small, and then you can see this has gone to what, 901 elements. So the entire console has been covered with these numbers. So this thing can like if you don't put the semicolon, you can see what stuffs you'll be printing out here. After, let's say if this size is like, I mean 900 is nothing. If you go in some 10,000, 20,000s, the history would be, I mean, what you had written previously would all vanish away, which is something that we don't want. So the best practice is to like give the variable, like you can see the answer is 901 values out here. So it is like just assign 0.01 and then 110 or whatever it is, and then put the semicolon, you'll be safe. You can see A has been assigned this value. Okay, so once that is done, so this is one way of writing out your values. The other way that I would most probably suggest, this is fine to get, I mean, once you're using loops and stuff, this is the best way to run your loops. But I would recommend something known as the linspace operator. So it does the same stuff, but you kind of know how many elements are going to come out. For instance, here you just specified the time as 0.01, and it went from 10, that from 1 to 10. The actual thing that happened was it was 10 minus 1 divided by 0.01, and that value with an additional plus considering the ends, you had 901 values. So 10 minus 1 is 9. 9 divided by 0.01 was 900. And considering 1 also, I mean, you have to add 1 again because you are considering 1 and 10 both. So you get 901 elements. So sometimes if you use this, you really don't know how many elements you're dealing with. But the best way to work out with this is to use linspace. Since you can say you are working from 1 to 10, and then you can say I'm dividing this with let's say 1,000 steps. And for now I'm printing. Once you do this, you can see all these are the values. I need to go really far back to see where we started off. Yeah, this is where I wrote the linspace. You can see how far these things have been printed out. And you can see it is like 0.009009 recurring. That is your step that is out here. So if you know, so the thing is, if you know the step size that you have to use the semicolon operator or something like this. And if you actually want to know the number of time steps that you are dealing with, just use this. And preferably, we'll be having information about a number of time steps, and this is how we'll be working. So use your linspace like this. You also have something known as log space, and that is log space 1, 10, let's say 100. This logarithmically distributes your numbers. You can see it's like quite a huge number. So yeah, it starts with 10 and then goes somewhere. Yeah. So this is another way of specifying stuffs. So any questions out here? Okay, fine with all. Yeah. Okay, so now let me give you some hands-on work to be done. So now you can say that yeah, so you plot a sine wave this time. So let us say how sine waves are plotted. So you just write sine of 2. It gives you this value. So you can spread out sine between, yeah, you can say from 0 to 1 and see how it's printed. So you can write, so if you just, let's say x is equal to, here you will write something. I would recommend linspace always. Let's say 0 to 1 and some 100 steps. Put a semicolon and now use sine as your y. Y is sine of x. And print this and see what you're getting. And plot this, I mean. Yeah, plot y comma x comma y. Sorry, always x is first. You will see partly this. I think you can increase this further. You can say x is 10 maybe, and then plot. So hitting CLF means it's clearing of my figure out here. And then once that is done, you can print. Yeah, you can plot this. So yeah, vary this thing and just plot this and see how it comes. And once you plot this, mark your positions. of your plots. So you need to know where your individual lines appear, and also vary 100 and let's make it 5 and see how it comes. So do excess linspace of 0, comma 10. Do this first. Plot as I have done. Then once you do this, plot those individual marker points with -0 that I had done previously. Then you'd be able to see how many points you have. Then once that has been done, you can clear your figure and then you can change this x to 5. Then again do y sine x and then plot this. So what we have done is we have stored x as this, I mean, it goes from 0 to, it's a vector that goes from 0 to 1 with 100 points in it. And then y of sine x is taking the sine of the, yeah, I'm sorry, I need to refer to this. It's going from 0 to 10 and you have 100 points. And y is sine of x is like taking the sine of each and every individual element. And then, yeah, and then it is doing the sine of each element. So the first element would be sine of 0, and then the last element is sine of 10. And these are all in radians, so they are not degrees. That is something you need to keep in mind when you're working with such programs. Always sine of some value, if it is given, it's always in radians. So do this, plot it with 5 and see what you get. I'll give you some 5 minutes to do that. You can also plot a green line, for instance, if you like. Yeah. So it'll be -0, dash O and G. You can also give a title. You can also include a legend that says sign. Okay, so let me. I hope you guys would have at least attempted. If not, I'll just show the stuff to you. So let me clear this figure. CLF will clear my figure, and then on top of that, if I do plot of x comma y, and so if I had to just plot the markers, it would look something like this. So you can see 100 points that have been spread out here. They're like equally spaced points. You might see them crumpled here, but it's like because the sine function is going this way, but they're all equidistant. Since we have used linear spacing, that is what lens space is. And then if you wanted to change the color, you could have done this thing. Just write G. G means green, and then your figure colors have changed. And now you'll see why lens space is actually preferred. Let me go back here, and why we chose 100 and why not 5. So if I wrote something like 5, and then I had done sine of x and then plotted this, it would look this ugly. So let me change the color of this to some red. Yeah, red would be nice. So you can see if I used 100 points, then you can clearly see how the sine function looks like. But if I just use 5 points, it gave you the right answer, but while plotting, it gave you an ugly curve which doesn't look like a sine. So if someone just gives you these values, so if you want to print such, I mean, if you want to display such a figure, you need to have a high resolution. That is why you use 100 points. Once that is done, yeah, so you that is why you need to use higher number of spacings out here. So this is nowhere looking like a sine function. And yeah, that's how. So there are multiple systems where if you just refine closer, you'll be able to understand the beauty of the nature of the plot. You can do a similar plot for this. So I'll just clear the function. Do lens space again, the previous one, and do a y, and then plot it as this. So this is my sine function. In a similar way, I can also plot a cosine function. So let me call this as z and cos of x and put a semicolon, semicolon so that it doesn't get ugly on your console. And then you can do the same stuff. And instead of xy, you'll be doing xz because you have stored cos as z. And then this time I'm going to plot them as, yeah, markers as 0 and red colors. So you can see clearly that, yeah, cosine starts when x is 0, it is 1. And then over time, it will, yeah, you have this kind of periodicity that is observable, goes between 0, it goes between 1 and -1, how you'd expect it to move like, yeah. So these things are about plotting. Any questions? Anyone stuck in between? Okay, let's move on. So we have done vectors now. So to generate vectors, you have two different types now. You can type it directly. You can create a linearly spaced. If you want a linearly spaced vector, you can do it that way. And then if you want specific elements, you need to make loops, which we'll be doing it later on. Yeah, do you have a question? Mehul. Okay, some question out here. So to plot graphs on two different figures, you have this figure command here, which is, let's say, F is SCF1. So you have created a figure here, and this has certain, so you can see this separate from the other figure. So, and then you create another figure called a figure F, let's say F2 is SCF2 equal to sign. So now you can see you have created uh, two different figures out here, and then for each figure you can plot stuffs within the figure. So you can see the attributes that it gives here. You have these things. It has figure sizes, figure names, whatnot. You can use all of these to plot. Yeah, so that's how you plot two different figures, and yeah, you can plot in each of the figures like that. So I guess it is f dot plot. Oh, I just closed it, right? Yeah. Yeah, I think you need, there's also axis out here, which you need to figure it out. Yeah, you'll be able to figure things out. Once you have created two different figures, you'll be able to print stuffs here. I need to check the actual specification of how to write it. Yeah, so that is it. It is not complicated. Just create two different figures. So this SCF is creates figure. Let me write once again. F3 is equal to SCF of 3. Say figure number 3. Now you can see graphic window number 3. And here you can plot your stuff. It also has something like axis. You need to actually read these things out and then use the write command so you can plot in this figure. Is it fine? So these are for two different figures. If you also want to plot in the same figure, you have something known as subplot. So where is this figure? Yeah, so you have let's say 2, 1, 2 in your figure. Your figures. Yeah, so subplots are also used. You can, I mean, you can look at the syntax of it, and then you can see one figure has been created out here. We need to have done CLF first. Subplot, and then in this plot x comma y. And then if you have the other subplot, 2, 1, 2, do the same, let's say plot x sine and cosine. So if you want to plot in the same figure, two different plots, this is how you do. So subplot is the syntax is 2 means there are two rows, one is column 1, and you're dealing with the first figure out here. And this is how this has been plotted. And 2, 1, 2 means you again, I mean, it's dealing with the same figure. This is your figure. So this entire box, what is given here, you're able to move. Graphic window number 0, that is your figure. And these are axes where your subplots are placed. So yeah, you would plot something like this here. And then you can have multiple subplots out here. That would be like, let me close this window to CLF. Okay. And then let's say subplot, let's say 2 cross 2. So 2, 2, 1. I have 4 figures now. And let us just plot the same thing so that we can save some time. I'm plotting this in figure 1. In figure 2, plotting the same stuff. Third one would be same thing, and fourth one would be here. So 4 different plots in the same figure. So this is how you use subplots. And for each plot, yeah, between these plots, you can write your own function. And I think for figures, it is the same thing. Let's say figures. Yeah. Yeah. The same thing, yeah. You need to just write the figure 1 and then you can plot it later on. This is how it works. So in 2 different figures, 2 different plots. But in your script, you need to write this ahead. I mean, you need to write it sequentially, then you'll be able to do. In the console, it is always confusing. So yeah, people don't usually code in console, and it's not recommended also. So for our basic understanding, we'll be working with we'll be working with these things. And then later we move on to the script. Once we are done with matrices, I think matrices and some polynomials, and we'll move on to the script writing. Okay, is this clear now? Subplotting and plotting in different figures. Yeah, okay, fine. Okay, let's move on to matrices. Um, Here you can see the different type that has come for those figures. I would, at this point, I'll just clear all my variables. So let's say I want to clear an individual variable and not everything. I'll just say clear A. If I want to just clear A here, I just press this. I'm relieved of that much of memory. The struct is occupying a lot of space. So I'll clear the struct and call reactor, and clearing the reactor. It's gone. Now I have some more space left. I want to clear everything. I'll just hit clear and then clear screen. And so always whenever you write your scripts, it's mandatory to clear everything and then start your code. This is just for, I mean, it's a good practice to clear your variables and then go. And yeah, so let's move on to matrices. So it's the same thing. You write your vectors as 1, 2, 3, 1, comma 2, comma 3. But this time you would say that, okay, now 1, 2, 3, I need to go to the next row. So I put the semicolon. I'll write 4, 5, 6, 7, 8, 9. So now you have your matrix. Even though it's called double, but you'd see your values are 3 cross 3. So you have 3 cross 3 elements. So when you have 2 directions, it's a matrix. And you have just one direction, if that is a vector. You have multiple directions, you have tensors. And matrix is the first tensor. So yeah, this is your first matrix. You have functions like maximum of your matrix. So 9 is the maximum value of your matrix. You can also find the minimum value of your matrix. That is 1. Then you can figure out the upper triangular matrix of this thing. So you can see the upper triangular is 1, 2, 3, 5, 6, and 9. You can see 0 has been extended out here. And in the similar way, you can also calculate the lower triangular matrix. So out of this matrix, it will give you the lower triangular elements. And you can see the upper triangular elements are all 0. So yeah, this is sometimes used in your calculations. I know you need to do an ALU type You can use this. You can ensure that it's an upper triangular matrix by looking at this. And then, yeah, you have norms of matrices. So this is something, I mean, I won't expect you to know, but norm is it's a value of a matrix. For now, just imagine this. Let's say you're given nine, so you have three cross three, you have nine numbers. You need to find out a value that is a singular value out of this. So let's say a magnitude of this, an equivalent magnitude. So what kind of magnitude? You have multiple definitions of the magnitude. So what is sometimes known as a Euclidean norm, or rather the Euclidean distance between these three vectors, that is what is known as the norm. You have multiple norms. You have norm 1, norm 2, 2 up to norm infinity. So you can define the magnitude of the vector in any type. So that is called as a norm here. For now, we'll just consider this. Uh, so when we are dealing with vectors, we'll be using norms mainly because yeah. So error calculations are done like this. So let's say you have two vectors, v1 and v2, and you need to like converge your values. You're doing some kind of a regression analysis wherein you're converging your values to a certain value. And so these norms are quite helpful to identify if the value of that you're looking for is actually matching the value that you're getting in your matrix. So you would expect that norms go to zero. So that is why norms are used. We look at this because we'll be using this lots in our assignments as well. So these are norms, and then you have resize matrix. So now let's say you have. Let me clear the screen. You have your matrix V, and then you want to resize it to something even larger. So resize matrix would give you V comma. Now you need something like 6 cross 6. So now you can see you have expanded your matrix from 3 cross 3 to 6 cross 6. And the remaining elements have been filled with 0. So let's say a matrix is increasing in some fashion, then you can use this. And most probably we won't be using this much. So there's something good to know. And then you have this reshaping of matrix. The resize is just increasing the number of elements, and reshaping is just given by matrix. So now there are several instances where you might not need this as a 3 cross 3, but you might need it as a 1 cross 9. I mean, you have 9 elements, and then just squeeze this and make it as a vector. So that time you do v comma 9. And then you can see it has been arranged in this way. So it considers column vectors first. So 1, 4, 7, 2, 5, 8, 3, 6, 9. It's all squeezed here. If you want to multiply it with another 9 cross 1, you'll be able to do it in a similar fashion. Yeah, that is what matrix is. And then there are several things like is matrix and stuff. This matrix of V is just checking if the matrix is true or false. I mean, if the elements are non-zero, then you use this is matrix. So this is something that you need to know. There are other stuffs like is square. So it just ensures if your matrix is square or not. So this gives you true, but if you take the answer and do something, okay, it's just giving true of true is true. So let us go back and then now do this. Yeah. So we had this as our answer where the size was 1 cross 9. And we were just asking if this is a square matrix, which obviously it isn't. So it gives the answer as false. So these things are like used for checks in your codes. Don't worry about them much, but we'll be looking at them later. Yeah. So these are all matrices. And then now we look at exploring how to access elements in matrices. So let me clear the screen. Let us print V once again. And now again, so we need to access elements. So we open these parentheses, and then you need to write the element, the index of these elements. So now since this is 3 cross 3, you will have two indices. One is specifying the rows, the other one specifying your columns. So here, so V of 1 comma 1 means this is the first value out here. If I do 2 comma 2, it gives you this particular value. If I do 3 comma 2, that is third row and second column, it gives you 8. So in this fashion, you can get out scalar values out of your matrix. Now, if you want to extract vectors, so vectors here are like rows and columns or just two elements. So for that, you would do something like this. So V of, let's say, all rows, you can say, yeah, first row and all columns. So that gives you 1, 2, 3. Let me clear screen, write V once again. And this time, let me print the second row. Second row would be something like this. I'm doing the same operation, but this time I'm considering second row. This colon operator says all rows, all columns. So you can either put colon here or here depending on your needs. So I want to print 4, 5, 6. So these are my values. So let's say if you want to print 3, 6, 9. So what would you do? Anyone in the chat, you can write down. Just print 3, 6, 9. Yeah. Chaturthya, you're right. Let's go back. So V of all rows and the third column. This will give you 3, 6, 9 out here. And then now let's say you want to print just 1, 2. So you would say it is as, it goes as V of first row, first two elements. So the is2 column can also be used to specify between the number of elements. So here I have 3 cross 3. If I had to increase this, let me just make a bigger vector. Say, so I have, okay, this is quite large. This is my vector, and I want to print the first three, or let's say, yeah, first three elements out here. So that will be V. So which row is this? This is the first row. And we are considering the elements out here. So if you do this, it's going to print the entire row. But now we don't need the entire row. We just need the first three elements. So for that, you would start with 1 and end at 3. Since you know how many elements you need, you'll be able to specify this easily. So this is how this thing is being printed. Similarly, let's say if you want to print 0.76 and 0.04, you would do something similar. You would go open this bracket. So 0.76 and 0.04 are uh, in the third column. So first write that third column, and these are like 1, 2, 3, third and fourth elements. So 3 is to 4, and that gives you 0.76 and point. Okay, have I? Okay, yeah, I mean, I've just done the reverse. It should be the other way. So yeah, this is the third column and 2 rows out here. So column number 3 and row is third and fourth. That's giving you this 0.7 and 0.48, 0.48. And so this is what is known as slicing of matrices, which we'll be using a lot. And there is also diagonal of these matrices that we might need. You have a direct function of that, which is known as diag of V. I'm not sure if you can also access upper diagonal. Yeah, you can also access upper diagonal elements. Let us clear this. So V is this thing, diag of V is these elements out here, 0.37527683. And then if I just put comma 1, that is over these diagonals. So it'll give you 0.26, 0.62, 0.39. And I guess minus 1 is the lower diagonals. Yeah, 0.73, 0.65, 0.04. You can try higher numbers also, like do -3 and see what happens. You will just get this value. So you can actually access, I mean, individually you can access, you can also access it diagonally. Yeah, so you have all these things. Now let me give you a position where you need to access these diagonal elements. So what would your logic be? The best thing is to do some kind of a transformation, do some transpose or something, and then you will be able to like resize your matrix and then get stuffs out here. So, I mean, once you start playing with this, you'll be able to figure things out. So, yeah, any doubts here? So slicing is something which everyone needs to know. Okay, great. Yeah, so yeah, I'm just curious. So how many of you are in your final year? I guess most of you are in your final year. Anyone in your second year or third year? You may raise your hands. Okay. Yeah, plenty of you. I understand. Okay, it's fine. Fine, fine, fine. Yeah, so so the main thing that you need to understand here is just look at, if you had done C programming, it would have been quite tormenting for you. Many things would have gone over your head, but don't worry with SciLab and MATLAB kind of programs. These are like quite friendly to the scientists and someone who programs like a chemical engineer or any other engineering field person or physics person. So these programs are like meant to be quite friendly. So with matrices and all, so those who were in the Python program would have seen that, would have written something like ASNP dot array and then written one ugly kind of expression that is 1, 2, 3, comma 4, 5, 6, 7, 8, 9. This is how the matrix was specified. And now compare this to the matrix that you are writing. So you'd write something like this: 1, 2, 3, 4, 1, putting 3. So you can see how much less you are writing here. So the thing is, such programs like SciLab, they are actually built on higher program. I mean, the programming languages like C, C++, Java, and Fortran. So in the back end, you have all of these where they minimize these kind of expressions out here. So for instance, in Fortran, you would write something like, I mean, you will have to reshape and all those things. You can write stuffs like this. You would be writing 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you would do some reshape of this. It would look something like this. And then there are like plenty. I mean, it is not as simple as this. So you'll find MATLAB, SCILAB having such simple expressions. So in other languages like C, C++, Fortran, you will have these like longer expressions. You will have to write some additional stuff, and yeah, that would yeah, make your code look a bit uglier. Uh, yeah, so all those things have been sorted, and then they have been quite refined, and then further like packaged into this application called Scilab, where it does these kind of stuffs a bit faster, so that you don't have to code, you don't have to write a lot of code for that, and that you'd be able to understand these things better. And here, for instance, every number is taken as a double, that is a real number. It is assumed to be a real number. But when you go to the basic programming languages like C, C++, you will have to define what the number is. So the type has to be defined first, and then you enter the number. So for instance, in Fortran, um, you would say integer a, and then you would write a is equal to 1. That is the thing. If you want to write a real number, you would write real a, and then you would write a is equal to 0.5. If you write integer as 1.0 also, it'll just crash off. It'll give you an error. So every time you have got to specify what your variable is and then do. Here you can see how convenient it is. If you just write r is %t, it takes r as a boolean. You don't have to specify anything. And also, yeah, if you take g is 5, it takes as a real number. It won't differentiate between an integer or a real, a kind of a floating number or something like that. So this is the advantage of using a programming language like Scilab. So yeah, for engineering applications, all your calculations and all, it's done pretty faster. Yeah, so this was a kind of background which I hope you would now realize why Scilab is better. Yeah, since MATLAB is a paid version, you might not have access. Scilab is a good alternative. There are also other better programming languages that are freeware, like Octave GNU, which are also quite good for programming. These languages are picking up faster, so I mean, it's good to know. Um, yeah, yeah. So that is a brief history of Scilab. And yeah, let us go and further look at some more functions on your matrix. So let me clear the screen. Let us consider this A matrix once again and take the inverse. So sometimes we need this. Yeah. Okay. So you might see, you might now appreciate all the mathematical things that you might have learned in your first 4 semesters. So you can see if the matrix is ill conditioned, you might have done these pivoting and all those things, finding inverse. And now you can see that why your matrix can be inverted or cannot be inverted. You can clearly see this is not a good matrix because I would expect the determinant to be closer to 0. Yeah. So this is, I can take a random matrix, maybe 3 cross 3. Then, yeah. So this has a decent inverse. So let me clear the screen, print A once again. This is just a random matrix that I'm taking. I need to be doing certain operations on this. So A is given. So the first thing is find the determinant of A. It is decent, not 0. Then find the inverse of A. You have some values of A that you might need. Want to invert a matrix. Then you can find the trace of A. That is summing up of all the diagonal elements. So for instance, let us say in fluid flow, you would say that if you consider an incompressible fluid, then the diagonal elements of the flow are, the trace of the gradient velocity is always 0. That is a condition for incompressibility. So you can like do a cross check and see if your trace is 0 or not. And then you have the rank of the matrix. The rank of matrix is 3. Yeah, you would have done all these calculations. You can also see the condition number of matrices. Yeah, it is 1. Decent. So yeah, these are some of the operators that you might need. So I mean, you don't have to make a note of all of these. They're all available here. So once you open this, you will find stuffs out here. So linear algebra, you can see matrix analysis, and all these things out here. Elementary functions you have. See matrix shaping, matrix resize, all what I said. I mean, there are plenty of them out here. So you have these lower triangular, upper triangular that we discussed. You also have several options. I mean, the list is quite exhaustive. So I would encourage you all to actually go and see all of these things. You have, these are all the features that are available out here. Yeah, so going back. Yeah, so these were the things with matrices. We will figure other things out. And now we need to look at the and or operators. So we know true and true is always true. So we put true and. So and is given directly as and. Percent T is true. You can do true and false is false. Similarly, true or is given as your single line. True or false is true. False or false is false. So these are the Boolean operations out here. You can see your answer is a Boolean. R is something that is stored as a Boolean. R is true. So I can do R. Is R true or false? That gives you true. Now because R was true. So these are your Boolean operations. So I think we have covered quite a lot. Does anyone have any doubts out here? We'll just cover polynomials and symbolic equations after a break. So let me see if someone has some doubts. You want to know something? Put here. Any doubts? Yeah, Ronak, do you have some doubt? Okay, so let's take a quick break and then resume at. Okay, so what's the time there? So we'll meet at 4:45. I think that should be good.
Okay. Okay, no problem. Take a break.
Yes, sir.
Okay, everybody take a break, huh? It is morning over there.
Sir, night time.
Night time, no? Okay, okay. Okay, we'll come after come at 4:45. No problem.
Yeah. You can practice these things out here, and then if you have any doubts, you may let me know. And we'll proceed further with polynomials and eigenvectors, eigenvalues. Okay, yeah. See you at 4:45. Yeah, so let's begin once again. I'll share my screen. Oh, I need permission to share.
You
Yeah,
can present
thanks.
now.
Yeah. Yeah, so we'll just cover some extra things with matrices. So let me create another matrix, random matrix, and then so we sometimes need find the eigenvalues of your matrix. SPEC returns the eigenvalues. So I think this also has two different inputs as well. Yeah. So you can find the eigenvectors and eigenvalues as well. So these are your eigenvectors and the eigenvalues. So SPEC is a command which is quite useful for us to determine your eigenvalues and eigenvectors. This is one important formula that came to my mind. The other thing is something like LU decomposition of A. Um, yeah, okay, you need two inputs, L comma U and LU of A. So you can find the LU decompositions, and yeah, in the similar fashion, there is also something known as QR. QR decomposition, just replace L and U with QR and just write QR instead of LU. Just do it and show. So this is used for orthogonalizing your matrix. I mean, at this stage, I don't think you'll be needing this. And there's also this Cholesky decomposition of A. Yeah, certain things need to be covered. So this matrix is a random matrix, is not positive definite. So how do we figure out? Yeah, you can see the diagonal term. Where is it? Okay, yeah. This is not positive definite, is what it says. So I mean, I don't want to go into the depths of it, but yeah. So this is these are three things. LU decomposition is something that you guys do quite frequently. So this is one thing that is important. So let me clear this. And now let's move on to polynomials. So for polynomials, we'll start with a simple polynomial expression. So let me create a polynomial out here. So let me write the polynomial expression as polynomial expression would be p of x equal to x squared plus 2x plus 1. So this is my polynomial expression. And then, so you can see the coefficients that need to be mapped. So for instance, yeah, so you write the coefficients as it goes as from x of 0 to x of 1, x of x squared. So you write the coefficients from behind. So let me take a better example by changing this to 3 or 4. So you write coefficients of this matrix of this polynomial is equal to 1, 2, and 4. So I'll write once again coefficients 1, 2, 4. So once you write this, this has been stored. And then you can use the poly function, p is equal to poly, and then write coefficients. And then you can write your variable. Your variable name is x. So once you do that, you can see your polynomial. It's displayed like this.
Why is there okay, let me just clear this. I think I need to clear variables because yeah, okay. Okay, fine. Let us work this out again. So the polynomial we want is, let's say once again, let me revise this. Take another random example. 5x cube plus minus x square plus 6. And then give this as so 6 is the first coefficient. Then you write 0, then minus 1, and then 5. So here you can see it has been marked as 6. 0 is, there is nothing for x raised to 1, so I write 0. Minus 1 is for x raised to 2, this is the coefficient. And then 5 is the coefficient for x cube. So once I write that, I'll write x as my variable, and then I can write this as coefficients. Once I do this, so this is my polynomial, the same stuff, but written in this kind of fashion. So it prefers to write polynomials in the increasing powers. So once this polynomial has been used, then you can use several functions. Like if you want to calculate the roots, so you just write roots of y. You will see the roots appearing out here. And then you can also do other functions like evaluate your polynomial at a particular value. So let's say I want to evaluate my function at 1. So I get this is my value. So polyval will evaluate your function, your polynomial, by substituting 1. So you can see 6 minus 1 plus 5. That is 5 plus 5 is 10. So this is your value here. You can also use, you can evaluate functions. I mean, you can evaluate for multiple values as well. So let me see if this is possible here. Yeah, this is the other way. So I've evaluated at 1 and 2. There's also the same harness function. Joshi sir, I guess you're unmuted. So there is another function known as Horner. It is equivalent to polyval. So you can use either of them. So polyval is something that I keep using. Joshi sir, if you don't mind, can you mute yourself? I hear some sound from your end. Yeah, thanks. Yeah. Yeah, so you have polyval where you evaluate the polynomial at a particular value. So for instance, here it was like you put 1 in the polynomial expression, you got 10. You also can put 2 and evaluate it at that particular. So you just substituted 2 here and you got 42. So it is like 6 minus 4 plus this 64, whatever this thing is, 4 cube, and what do you get the value over there? Yeah, so once that is done, yeah, so we have found out the polynomial. Then we have found its roots, and then in the polynomial, if we have to substitute a particular value, we do this thing. So we evaluate the polynomial. Then we also have, yeah, you can take the derivative of this polynomial. So that is also another thing. So let me just clear this thing, display what y is, and then derivatives derivat, and then put y. So you can see it has taken the derivative of this and it's expressing it over here. So this is how you express your derivatives. Integration is not available as of now. or it could be in some particular toolbox that I'll let you to discover by yourself. But yeah, so I think we are quite happy with derivatives for now. And yeah, so these are the derivatives. And then you can also use a particular polynomial as a symbol. So if I say I want just x, so I just write poly and then put 0, comma, and then just take x out of it. This gives me x. And now once if I have x, I can do any kind of polynomial expression of 4x plus 5 and call this as y or z. So I have my own polynomial expression. Here you can see these things over here. You can see polynomials. The type is a polynomial now. You have x, y, and z as polynomials. So x and we'll be playing with x and y now. Once you have two different polynomials here. What have I done? Yeah, okay, fine. So now I can add polynomials. So y plus z is the addition of polynomials. Then you can multiply polynomials. You can do y star of z and then can calculate this. You have multiplied two polynomials, and then you can also plot polynomials. So for instance, I can take x ranging from, okay, this would be a bit controversial. Take some other variable. Say n is equal to minus 10 to, yeah, 0.1 is to 10. Let me vary it like this. And then I can take, yeah, I can evaluate n. So I'd use polyval to evaluate my y function at n points. So this is the advantage of using it. And then once you do this, okay, I didn't press the semicolon. And then you can just plot plot m comma n. N was x, yeah, so n comma n. And then maybe plot the markers and see what comes out. So you can see this is my polynomial expression. Too many points, but fine. And once this is there, yeah, so once you have the function, you can, I mean, you're good to go. Anything else? Yeah, I think this is fine. This much is enough for polynomials. So let me, I think, clear the screen and write what we did. So n was this thing, m was this thing, and then we plotted these values. Yeah. So these were the commands that we use. So now, for instance, you want to find the derivative of this, of y, and then plot that as well. So what you would do is take P is reserved, take Q. Q is equal to derivative of y. Save this, and then now plot. And yeah, you need take R is equal to polyval, and then your function is Q. You are replacing it with n's, and take my the semicolon, and then now you can plot n comma R. You can see how the derivative looks. I can give a separate color for this. So this is your derivative. You can see when you have this inflection point. So it is good for you all to understand how polynomials work. So this is once you look at this, you will be able to clearly say that the nature of the polynomial is of the order of 3. Because if it is the order of 2, it would be a parabola. Then it takes these curves and like it'll then further moments will take it'll further go down and then go up, or whichever way you have your convention. I think it'll be a parabola, then it'll have this inflection point and again a parabola. And once you see you have a particular inflection point where your derivatives are 0, which is quite clear here. So inflection points are where you see your slopes completely changing. It goes to 0 and then goes negative, positive to negative. The derivatives of these are like they have, a third order polynomial would give you a second order polynomial as its derivative. So you can see the nature is a parabola. And then further, if you do it, it's going to be a line. Well, let's plot that as well. Polynomial, polyval. Q. So this is a line. And T is equal to polyval of S comma N. And then you can see this is a line, and it has a very tiny slope. And then eventually you take a further derivative, you will find 30 as your value. And yeah, since these orders are quite high, you can see that so there is one more thing that you can do is if this plot looks ugly, you can also take a plot of a logarithm on your x-axis and y can be normal. So you have a convention for that. So our first plot was n comma m. So let me write that one, n comma m. And then that was, okay, let's leave that. And so here, if you want to do a log plot, you would write LL. If you want your x-axis to be normal and your y-axis to have a logarithmic plot, then you do this NL and then you plot that. Once you do that, you can see your logarithmic plot. It looks something like this. So yeah, since we had very high orders, we can see that, okay, 0 is somewhere here. This is where that inflection point is there. And then further it went down. You can figure this thing out. It was, the inflection was not at 0, by the way. Yeah, sorry for that. Yeah, it had some finite value. So you can see it turn over here. And then further it had some particular value. And it's not showing negative values, obviously, because you can't have negative logarithms. So this is the logarithmic plot on your on this particular axis. So I'll close this. So we are done with polynomials. And finally, the only thing that we'll mostly use is something that I've kept for the last of this in your, the console part. So let me clear this. So this thing is known as matrix multiplication. So we'll be having systems which have AX is equal to B form. And we need to find what X is. A and B are known. So, you would have come across multiple systems where you have this AX is equal to B kind of thing. That is, if you have linear equations, a system of linear equations, you will surely have this AX is equal to B form. Sometimes you might have some nonlinear equations that could be reduced to an AX is equal to B form and then be solved. So in your undergrad, you deal with these two kind of systems. So so this is quite important. So if you have A and B, so let us take a 3 cross 3 matrix. A is equal to, again, I would not sit and write another matrix once again. I would just take 3 cross 3 random numbers. B is also a random number now for me. Uh, B is a column vector, so I would write it as a random number that has 3 rows and 1 column. So if I write it like this, now I'm safe. A and B are well specified. If I want to find out X, I would write X is equal to lin solve of A comma B. So once you do this, you have solved for X. If you want to cross check, just do A star X. You will get your B matrix again. Are you showing negative values? Yeah, because some strange convention. Yeah. Okay, fine. Yeah, you can. It would be better if I do it on. Here is giving the same value but a negative number. I'll figure this thing out. Yeah. So you just multiply it, and I mean this will solve the equation for you to give you your B matrix. Yeah. So this is the most important thing that we need to know. That is the lin solve function. So does anyone have any doubt? Are all clear with this? Okay, so if you are clear with this, let us now begin uh, with your scripts. So the first thing is, let me clear this. So now we'll start with writing scripts. So I'll clear this, close everything. So I've cleared everything. And now once you go here in your applications, you have something known as sign notes. And this is quite, yeah, I mean, this is the text editor of Scilab. So the thing here, the painful thing to write here was like I made let's say if I make an error, I got to write everything again. You can't write something continuous over here. So you did see when I wrote I had taken the derivatives of a polynomial. I had to write multiple times. So in your to avoid that, you can just write a script for the same, and then for that just open notes. Pop-up window will come here. I hope you can see this. Once this window comes, do you have a doubt, Mehul? Are there some questions out here? Yeah, someone has a question. What if I want random numbers as integers? I think you have a function called randint in your in the same place. Let me try. I mean, randint is used in multiple places. I guess this is the same syntax. Yeah, forgive me for these things. So I keep using Python and stuff. So you'll have similar conventions like this. I guess it's the rand and random. You need to check here. I mean, it comes under the random numbers. Uh, you will have a random number generator. Let me just cross check it here. So it is called grand. That is all I can see here. You will figure it out. I mean, there are multiple functions out here. You really can't remember each and every function. So just you can search for your things in the, you will get the particular function that you're looking out for. I mean, don't break your heads on the names of the functions. You can eventually find and then use. The only thing that matters is you need to know how to apply these functions. And I mean, if you seek for the right function at the right time, you will be able to solve any kind of a problem. Yeah, so that is the thing. And yeah, we'll start with um, these sine notes. Yeah, so once you open sine notes, it looks like this. Go to applications, open your sine notes, and then what you can do is you can just grab this blue color thing and then drag it here. This is something that I like to do. If you like to write your text in a separate box, you are most welcome to write. But I kind of like to look at my variables and other stuffs in the same section. So I do this thing. So you'll find me writing scripts in this kind of a format. I would increase this size here. And so you can save this at a particular location. For now, you can just, yeah, I'll just save it in between. So the first script that you can write is, as usual, no guesses. Everyone writes hello world. We'll also write the same. You can save this. I'll just do some setting. So once you go here, you can set your directory. I would just set mine after I'll stop sharing and I'll just set my directory and then get back to you. So go to that folder button on top, and then you can set the particular directory that you want to work on. And then once you do that, yeah. So here you can see I have set this as my working directory. So it's important for you to select your directory. I already have a folder of T6 SCILAB certificate course kept in my folder, and this is my working directory. So whatever I store or run would be happening in this particular directory. If I want to access any other folder or any other file in some other folder, I'll have to give a command similar to that. So this is my working directory, and I have opened sine notes here. So let me close this. I'll show another way of so you can so the thing that I've written here is hello world. I'll just copy this. You can do this, save it as a file, or else just directly start off here. So you can do an edit function, edit, and then write your file's name. So I would write it as .sc. .sc is the extension. So once I do this, you can see it'll ask for a particular file name. And then if I say yes, then a file name of that thing would be created and you can see it here. So once this is here, you can just put it here. So I've created my file. It is here. You can see this file has been created. Just go back and you'll be able to see the file name. Once this is created, you can start writing. So I'll just write hello world once again, save it. And then you need to click this run button. So once you hit this run button, you can see this has been displayed. So I have displayed a string. This is your, I would expect all of you to write your first script here. Yeah, just work with hello world first. And yeah, keep writing everything. So write first script of printing a string. Your first script. Then similarly, you want to print numbers or vectors. So just write v is 1, 2, 3, and then insert semicolons, print v. Oh, sorry, print is typical Python. I'd say display v, and then you can hit run. Yeah, you need to save and execute always. You can see hello world has been written, 1 to 3 also has been written. So now the function of hello world is done. So I'd comment this, or rather you all can take your time to write this in your script. You can also display a matrix. And then right before this, I'd also like to print a scalar value. Scalar value is nothing but your variable. So let me call that as a is equal to 5.3. And then to print this, I'll use a different function. I mean, I can use display, but for showing you guys, I'm using this smprintf. This is also an inbuilt function. So I would write %d and then a. So you can see 5 was printed, and then 1, 2, 3, and then this matrix. So I want to have a good spacing out here. So what I would do is, so you have a spacing immediately between different types. That is, it is entered. But here typically I want an enter after A. So that I would just write a backslash n. Backslash n means new lines. So you have multiple commands like this. Backslash t is tabbing and whatnot. I mean, you can just figure you if you open uh, the help menu, you will be able to figure out all of these things. So once you hit backslash n, you can see that this 5 will be in a separate line and 1, 2, 3 will be in a separate line. So let me run this. Save and execute. You can see 5 has been printed here. 1, 2, 3. Now I want to, you can do the same thing for, you can just make a simple line shift here. Yeah, so I've just added a new line here in between so that you can differentiate between the matrix and vector. So this is the entire script. You can write it here. So we are printing a string, we are printing a simple variable, we are printing a vector, we are printing a matrix. That is pretty much all that we want for our purposes. And I also want to tell you guys, if you are like writing the program side by side, so you can open two different, I mean, you can just bifurcate your screen to having the teams on one side and your code on the other side. So that will be easy for you to copy and write stuff. So for those of you who are like not initiated into programming and stuff, so here you can see in the script, I had just written everything once, and you can see how many times hello world has also been printed. So you didn't have to write hello world multiple times in your console. So it's like you wrote it once and it's done. It's going to be there forever. And the only other thing you need to know for a scalar value is, let us say you have multiple numbers in between. And now you say that I am so used to working with just 4 digits after my decimal place. And I just want to print 4 digits. So I just put 0.4 before the D. Uh, D is your double type. So once you do that, you can see here. It's going the other way. What is wrong here? Yeah, it is F. Sorry. So D is okay. So my apologies. D means an integer, and F means floating point. It is quite confusing here. So D and I can be used as integers. So if I put I also, you can see this will give me 5. So 5 is the integer that comes out here. 5.1 is considered as 5. And if I put F and just put 0.4, and then save this. You can see the first 4 digits being printed out here. So just make this tiny change out here. Instead of D, just print F. %F. And here you can also see that it rounds off your value. 4, 5 is taken as 5. Yeah, so once this is done, I hope anyone still writing? Okay, fine. So we'll continue further. So, I mean, those of you who want to write in a different file, you are most welcome. I would continue writing the same file, but I would comment these things out. So I'd select all. For those who don't know, the comment file is somewhere here, comment selection. I'd prefer doing it as Control D because I'd be doing it quite often. And then Control Shift T will uncommented once again. So let it be as commented values. This is my first section. So right before that, partitioning is important. Okay, so let's go to the next part. This will be on different loops. The most important thing that we need to learn. So in loops, we'll be looking at for loop. This is the most widely used for loop. Yeah, this is the most widely used loop. In this, you just write for I is equal to 1 is to, let's say, 5. Then you write display I and then end this end loop. And then save this, run this. There is some syntax error. Oh, two ends have come here. Okay. Save, run. So you can see 1 to 5 has been printed. I use display I. The equivalent of this is Control Shift T. Oh. Print F and then write %D and then I. This is the same thing. I'm printing the integers, but this time you can see it's printed in the same line. So I would write a new line after every sentence. So now you can see 1, 2, 5 has been printed without these dots. So dots represent that is 1.0 and that's a double value. These are all integers. And then you can, you can also do 4 dots. 4 before the number. It's printing 4 numbers before. Here it takes as spacings. So you can see 4 spaces here. 1, 2, 3, and 4. I just highlight 1, 2, 3, 4. You can see 4 spacings here. So it has used this much of space and it's giving you this tabbing. You can also use tabs instead of this printing. I'll remove this 0.4. And print it as print in this manner. So let us go back to the origin. This is just for you to understand how to print different stuffs. Control D, okay, Control. Just use the display. We won't be differentiating between an integer or a double. Yeah, this is fine for us. Once this is done, you have created your first loop. Then you can modify certain sections. Now let's say I want to print the first 10 numbers, first 10 integers. Then you do this and then just say if n is, let's say, 10. For our case, you just run it. The same code works for 10 integers. So whatever you change here, it will change accordingly here. Many of you who have actually run scripts on SCILAB or any other coding program, they'd usually take something as input and then they would write an input over here and then wait for someone to actually enter something in the console and then work it out. For instance, this itself n is equal to some input they would write and then wait for someone to enter that value of n. The best practice is to just let it be in the script. Do not use input at all. 99% never use input unless if it is specified for a specific reason. It is good to write in your script itself. So if n is 10, just open your script, edit it over there, and then finish it off. Worst case, you can create a separate text file and then keep all your inputs there and then write, but never use the console to write your inputs. So here in this case, 10 was the input. So we have written a for loop that goes from 1 to 10. Now we can do something, some different stuff. So this was printing first and integers. You can also write a code for printing the sum of first and integers. So in this case, I'll just copy the same stuff. Copy it, comment it. I'm no longer using it. And here I'm going to sum everything. So I'll initialize, so let's say a sum variable. Sum is a keyword, so I'd use sum1 is equal to 0. And here, instead of displaying I would just write sum1 is equal to sum1 plus I. So the logic here is, let us run it for a lower value. Let's say 2, and then print sum I. Sorry, sum on display. So you'll know how this thing works for those of you who are not familiar. So you can see what happened is n was 2. So we are looping through this twice. So this is equivalent to saying that at first what we did is we did 0 plus 1, and that is equal to 1. And so this displayed 1. Now sum is 1. So now what we are doing is 1 plus I. Now I is 2. First I was 1. 0 plus 1 gave 1, and then it displayed 1. It goes back. Now I is 2 here. If I is 2, 1 plus 2, 1 plus 2 is 3. So that is what it printed out here. So you can print up to multiple numbers. Let's say like this. So the sum of first 10 numbers is 55. And I don't want to be printing all of this. These are all redundant data for me. I would just remove this line and print it outside this line. So this is a compact way of writing the first n integers. So I'll save this, run. Just see 55. So does anyone remember the direct formula for calculating the sum of first n integers? You can raise your hands if you know what the sum of n integers are. You would have done this in your mathematics. Never mind. I would give you the answer. This n into n plus 1 by 2. You can just verify once again. So n was 10. 10 times 10 plus 1 divided by 2 is 55. We did the same thing, but we did it in a more longer way. So now you can see stuffs out here. So this will also take some time, and you can measure the time of some certain things. So for instance, if I say T1 is, I hope this is the right nomenclature. And just see. Okay, it's directly it. So once again, forgive me, as I'm like I do multiple programming languages, do get confused. a lot through. And yeah, so you can see the time that this thing took and compare it to something like the direct formula. D. Use the direct formula. Okay, if I increase n to a very large number, you'll be able to appreciate this. Yeah, see, I had 10,000 numbers, and usually, I mean, I use this for loop to calculate the sum of first 10 integers. And this is a typical way. Let us say you were some person from the yesteryear's era and didn't know that a formula like this even existed, where you could actually find out the sum of these first n integers. You just blindly would like take, you would add 1 plus 2, 2 plus 3, 3 plus 4. And for that, you would do something like this. That is, you would use a for loop, individually just like keep calculating 1 plus 2, 2 plus 3, 3 plus 4. And then when you went to 10,000, you would get your value. And then, so this is what the for loop does. And that took, you can see, it took a very long time. But if you use this direct formula, which usually people do, I mean, it is the best if you could get this is what is known as an analytical result, where you have a direct formula, just substitute the values, you get the result. We had a formula, I just wrote this thing, it didn't go through the loop. So the loop, every time you go, you pass through the loop, it will take some time. And for like, if like one loop takes a particular number of time, n loops would take that many number of times. So n times the time taken for one loop. And here this is a direct formula, so it's like just reading it out in one line. So whatever time it takes for just running one line, it will directly display. So you can see the difference. So it is like good to know your basic fundas, whatever mathematical expressions you have. So this is one good example that has just come out of the blue. So yeah, for now you can just write this, and yeah, you can display both. Doesn't matter. I can comment this thing. We don't need this. Yeah, but this is also important. The stick and tag, these two functions are important. So I'll just comment. Yeah. So we have done this. This is our for loop example. Let me save and run once again. So you guys can write this. I mean, write the entire thing. And yeah, it's better for me to wait. So let us write this first. Yeah, take your time to write this. You can also write these statements. It would be good if you write store this as I'll wait for 3 minutes and yeah. And also write semicolons. I might have missed at many places. Yeah. Yeah, have all of you written this? Uh, if someone is still writing, please raise your hands. Okay, I guess all of you have written. Let's move further. Yeah, so I'll comment this out. The time values. And yeah, so we have two numbers. Now the next thing that we would be interested in is uh, to do checks. So this is for loop. I mean, I'll just quickly go into this if loop, and then we'll come back to another example of for loops. Maybe I'd give you some a simple example for you to work on with. So we can, yeah, we can check if both these methods are giving you the same answer. So you have some int and some one. So if you just say if some int is double equal to some one, this is the way you check if your function is right or not. Then say uh, and then you also have an else condition, else so this is the way you check it. You can try adding a small perturbation and then see what happens. Formula doesn't work. So this is the if statement. So usually we keep a lot of checks in our code, and these if statements would be within a for loop. Yeah, since we just randomly came up with this example, like I felt it would be good to tell you what this if statement is. You can also do if this thing is not equal to this thing. I mean, different conditions you can place over here, and you'll be able to get your result. So write this down as well. Yeah, so not equal to is, I'll write it down. So these are your logical operators. You have equal to, not equal to. You have something known as greater than. So 2, 3 greater than 2 will give you true. Then you have less than operators, 2 less than 3. Then you can say 3 less than equal to 3. That is 2. I mean true. 2 less than equal to 3 is also true. So you have multiple things. So equal to, not equal to, and then greater than, less than, all these operators you can use over here, which is usually used in your if condition. Okay, so for those who have done this, we'll give you one exercise. So the exercise, your first exercise in this course will be print the first 10 odd numbers. So let us see who can do it fast. So I just want someone to this would be display I in the particular exam in the exercise. Don't write this line. Just write display I and the same stuff. N can be, what numbers? 10 odd numbers. N is going to be 10. I'll just replace this as 10. Same code. You'll be changing something here. So what is it that you need to figure it out? Whoever figures it out can comment on the Q&A session. So I'll be waiting for until someone types it out. N could be 10 or it could be something else. Yeah, you need to figure this thing out. Or yeah, you change N also. You will have to change N in this place to get the first 10 odd numbers. Yeah, that's also a way to write. Very good. Can you change? So I want you to change here. What would you change here? Just write display I. You can change N also. You're free to change N. So that is one correct answer. That what's your name? Yeah, Sam. Yeah, good that you've got the right answer. But I would recommend you to change it here. So the thing of doing that again, we can see it in your if you do the timings. Uh, you would see that every multiplication takes a time, every subtraction takes a time. It everything costs something in computational time. You want to minimize that. So it is like better to directly instruct it in your for loop than like do a multiplication and subtraction that is going to be happening 10 times. So remember one thing. Yeah, so I'll since you have given me one answer, I can give you the other answer. So someone has written something. Yeah, that is one way of, the same thing. He has written the same stuff. I'll show you another way. So that is to use something known as, so we did 0.5 in between, if you remember. So you can just do 2 this time here. And maybe make this what, 20 or something. And just, yeah, Save this, run it. This is printing what? 1, 3, 5, 7, 9. Yeah, you can see 20 numbers being printed. I mean 10 numbers being printed here. So 1, 3, 5, 7, 9. Whatnot. Yeah. So this is one way of working things out fast. So here the advantage of this thing is that it took at this level itself, it took I is 1, then it took 3, 5. Here itself it did the calculation. Anything that you use as an inbuilt function is always faster. If you manually do 2 times I minus 1, so 2 times I is going to take some time, minus 1 of that is going to take some more time. So eventually it becomes slower. So yeah, good for whoever has done it. Well done. Yeah, you're not wrong, but yeah, I mean, it's good to think in other ways as well. Because in future, you'll be right, if you are working in this field, you'll be writing codes that would take days. And then such small things would add up your time. I mean, you don't want to spend another day by just doing some operation that is like quite trivial. And yeah, so yeah, it is good if you start thinking in a way where you can really save computational time. Yeah. Okay, good. So we are done with odd numbers. You can work with even numbers as well. Just start with 2 here. You will get even numbers. And then yeah, you can I mean some crazy things that you can do is I mean this is something that people usually, I mean you would have seen the news also. You can find using such for loops, you can find these prime numbers. And I mean, you would see latest in the news, someone found the largest prime number. So, I mean, in the mathematical community, such things are like quite. So, I mean, every prime number that is the largest one that has been found is always like a paper by itself. And nowadays, people are using, I mean, they're using these AI generated stuffs to really figure out some formula. So you don't have a direct formula that can tell you how to identify prime numbers after a certain limit. So even when you learned about prime numbers, I bet you would have like seen the prime numbers till 100. And then beyond that, you would have no clue as to how these prime numbers are like quite related to each other. So finding some prime number that is like super large. So I think this guy who found out had 2 raised to the power of some 6 or 7 digits. And that's a crazy number that you even cannot display in a computer. So uh, you have something known as Mersenne primes. I mean, there's an entire field where people like really push their limits to find out the largest prime number. So yeah, that is also something. If you do with your for loop, uh, if you really want to find a number that is something as large as uh, the current world record of the largest prime number, first thing is you won't be able to find. Second thing is even if you let your computer run the code, I mean, you just put a for loop, then see check the number. So the code will be like this. You will say for I is equal to 1 to whatever infinity, then you see you take I and then divide with the previous numbers and see if it is divisible by any of the previous numbers, then it is not a prime number. This is the if statement. If it is divisible, it is not a prime number. If it isn't, then it is a prime number. So that will be the logic that you set up here. So once again, I'll repeat. You have a for loop where you say I goes to, okay, I can write it down here. Prime numbers, just the logic. I'm not going to be writing the code. If you're interested, you can calculate this. So it'll be like for I is equal to 1. I need to comment everything because for I is equal to 1 to infinity, then you will see so check if the number is divisible by any of the previous numbers. Then you have an if statement. If yes, then print. If yes, then it's not a prime number. Else so this is some kind of a pseudocode that people, I mean, what you initially do to search for prime numbers. I mean, you won't be able to go to the infinite domain using this. Yeah, this is some kind of logic. So you can see you run your code from 1 to infinity. I mean, you have to let it go. So yeah, you have to let it go for infinite time. Then you'll have some logic by which you can check if the number is divisible by any of the previous numbers. That itself is like, I mean, you'll have lots of lines of code. If that logic says yes, if it is divisible, then you say it's not a prime number. And if none of the numbers before that are divisible by this number, then you say it's a prime number. So this is how, I mean, this is the logic that people use to calculate prime numbers. The advanced one, you can, I mean, refer to any of these prime numbers, and people, and this is the domain of what people usually say as, I mean, it comes under abstract maths only because uh, people, you don't, it is applied in some sense, but yeah, people, it's always what you do in abstract maths comes into what is known as applied maths. And as engineers, we are always in this domain of applied maths. So yeah, to find out something unique, you always have to go into the abstract maths side and then figure out things. So for instance, I can give you this example. I mean, I've told before also um, in during my Python course. So, for instance, there was this knot theory. I mean, the knots that you use for tying up ropes and all those things. So, so mathematicians had done crazy stuffs on just knots and other algorithms. And then recently, if you would have heard about these quantum computers, out of nowhere, these knot theories happen to be of quite use to these qubit calculations, and I don't know, I mean, so something sort of that. So what was abstract maths is now applied maths. So yeah, you never know. I mean, whatever you're doing in abstract maths could be useful somewhere to someone. Yeah. So yeah, people do such crazy things. Yeah. Anyways, it contributes to science. So yeah, I hope this inspires you to do something also in the field of maths. Yeah, and programming is one such. I mean, it's one such expression that could help you to realize something like that. Yeah. So okay, let's get back to the discussion. So we finished with for loops. Uh, we can. So what is left? I think while loop is left, and then we'll end our discussion. For has been done. If statements have been done, and while loops finally. So I would like to comment all of this. I was printing a lot of other stuffs. And finally, while loop. So in your while loop, you can have, let us say let us say j is 10. You can say while I is less than j. So this is one condition that you need to place before while loops. And then once that has been done, you can just say display I, and then increment I. If you don't increment I, this is going to run forever. I plus 1, yeah. And initialize I also. So let us see what happens if you don't initialize I. I mean, if you don't run I. So this thing is like j is 10, I is 0. If I is always going to be less than 0, display I. So let me run this. It's going to crash. And let me clear the screen and then save this and run. And see, it's just printing 1 1 1 1 forever. So to stop this, you have to run Control C. If at any point of time you, while playing with while loops or even for loops, if it happens to keep printing infinite stuffs, you can just hit Control C to stop your code. Someone unmuted themselves. Okay. Okay, fine. Now we'll just quickly cover this. Yeah, so to stop this infinite loop, we keep incrementing this I, and then you will see where your program will stop. So you can see we had given this condition that I shouldn't be exceeding 10. So in your code, you can see uh, it's going from 0, 1, 2, 3, 4 till 9, and then it stops because it is going till after this point, it is becoming 10. And if I is 10, this doesn't hold true, it exits this while loop. And that's how while loops are constructed. There are other ways of constructing while loops also. This is one way. And I'll write while just true. You can just write while true. I mean, you don't need any condition also. So you can say, let's initialize I is 0. I mean, we'll use the same logic. Here we are not using I is less than 0. I mean, I is less than j. We're just going to be using I is 0, and then we keep incrementing I is equal to I plus 1. And here we can write an if statement. So there needs to be some condition where this thing comes out. So if you write an if statement, if I is less than j, I can write the same j here. If I is less than j, then you can write break. Break is the condition that you need to write. And yeah, keep putting semicolons. It's a good practice. I mean, I do keep forgetting. Best is to keep writing semicolons. You can write end or end if, and while is also a good way to say where you're actually stopping your while loop. Because there are like multiple ends, then you won't know which is which one. So this is another way. I'll comment this section, Control D, and then let's run. Save and execute. Okay, and okay, fine. This doesn't work. What is wrong? Oh, I didn't print anything, right? I need to print type.
Oh, the condition needs to be the other way. Right, sorry. If I exceeds 10, then we stop. This is what is happening. Otherwise, this is also an infinite loop. So while loops are like kind of an infinite loop that stops under certain conditions. For loops are quite straightforward. You know where it starts, you know where it ends. So these are the two loops out here. So you can write this down as well. These two are write while loops. So does anyone have a doubt? Oh, someone has written something.
Doubt? Anyone has doubt? Put them on in the mobile.
Yes.
No one has doubt. I think we have muted everyone. Na? Just a minute. I will see whether all can be unmuted.
Okay, thanks, Chatut. Yeah, so those who are like writing these things down, you can write this as well.
Now attendees can ask questions. I unmuted you. Attendees can ask question directly now. No need to write.
So does anyone have any doubts in whatever we covered here in 4 hours? So, I mean, if you have some doubts, do ask now, because further, when we'll be going into details, it'll become a bit difficult for you to understand. If it is clear now, you'll be able to understand later. Yeah, so I guess no one has doubts. So I think that's it for today. Those who are writing can even take a screenshot of this, or maybe you can look at the video later on. So yeah, so this is done for now. For the next sessions, does anyone have anything, any suggestions for what can be covered in the next sessions? Is there something that you're particularly looking upon that I can cover up? So it'll be easy for me to also prepare something that is relevant to you. I do know that you guys are doing MSO practicals, some of you. And for those who have done numerical methods, I can also make a revision course over here. But if you are looking at a particular, I mean, a system that you want to work on, or a particular problem, or any of your B project, um, I mean, system, we can address that as well. So if anyone has any suggestions, I mean, yeah, you can put it in the WhatsApp group that you want this particular topic to be covered. I mean, we will eventually get there, even if it is an advanced topic. Let's say if you're looking at reactors, you're doing network of reactors, you want to like write codes of them, or maybe you're working on some particular uh, reaction system, or maybe do some regression analysis, something. You want to do optimization. If you're doing process control, SCILAB is a good place to step into. We'll be covering process control stuff also. There's a separate module in SCILAB known as XCOS. So we can explore that as well. So yeah, you can suggest. I mean, if you foresee any of your final year project stuff coming up, you can let me know. Yeah.
Okay, you can even post it in the WhatsApp group. It is not, you don't have to post just now.
Yeah. Or you can, if you are not willing to share it with everyone, you can personally mail Joshi sir. He'll let me know.
You can mail me also. It is not a problem. Okay.
Yeah.
So I think it is enough for today.
Yeah, yeah.
I thank Aditya for taking this efforts. A very nice lecture also.
Yeah,
Even I
thank
also
you.
understand a lot of things.
Yes.
Okay. And then tomorrow lecture also will start at 2:30 once again.
Yeah.
Okay. Thank you very much. So should I end the meeting now?
Yeah, yes, sir. Yes. Thanks a
Okay.
lot.
Thank you again. Take rest. Okay.